All right, so today in civil engineering is the day that we are looking at wastewater management. This is how we get the wastewater from a toilet, from a shower, from a dishwasher, from the laundry, from your kitchen sink, out of your house and to a treatment center to be processed. There is a Project Lead the Way wastewater management presentation, so we might as well take a look at that. And if I play that from the beginning, these are the things that are in the wastewater management PowerPoint, so let's just get to it. The first thing that happens is we do reuse a lot of the water that we have leaving our houses. The water that leaves your house, whether it's from a toilet, from a bathtub, from a sink, goes to a treatment facility, and when that gets to that treatment facility, they do treat that water. That water gets put back into the system and it does come back to your house. So the water that we're using is constantly being reused in the cycle over and over and over. When it gets to the site, that's where it's treated, whether that's state owned or municipality owned, and then it comes back to you, and there you go. When they treat it, they do one process, that's screening and settling, so all the solid debris is removed from that water. And then they treat it with biological bacteria that basically eats all the pollutants that are in it. And then finally they disinfect it before it comes back to your house. In the entire presentation, this slide is probably the most important one out of all of them. And the slide that I'm on right now talks about some of the mandatory requirements that have to be put into your project. Otherwise, you are in serious violation of your code. So for a regular house, the wastewater leaves in either a 3-inch pipe or a 4-inch pipe. And I'll show you how we determine what that's going to be in just a moment. If we have a larger building, such as a school, that we're in right now, or something like Pfizer Forum, then you're going to need a much bigger pipe, because at Pfizer Forum, when it's halftime at a game, or in between quarters, or in between periods, or in between shows, when one artist is done and the next one begins, everybody goes to the bathroom at the same time. So all of those facilities are being used at the same time, and there's a lot of wastewater generated at a very fast amount of time. So the lateral could be bigger than a 3 or 4-inch pipe, but for a normal residence, that's what we're going to use. The depth has to be at least 2 feet below your floor. Whatever the lowest floor is, the sewer line has to leave 2 feet below that, and it has to be below frost depth. So it's whichever one of those is greater. So if 2 feet below your floor is what it is, then that's what you use. If it's at frost depth, then that's what you use. The minimum sewer lateral for most cases is going to be, the minimum lateral slope is going to be 1%. It has to flow. So you have to have a 1% slope minimum for the liquid water to run in a direction. But that could be different depending on what type of pipe that you're using and where you're at. We'll get to that in just a minute. This is also very important. The sewer line must be below your water supply line, so that if it leaks, the leaking sewage does not run over the water supply line coming into your house. You do not want people drinking contaminated water. If both supply lines were to be broken, the sewage water would get into your drinking water, and that would be bad. So the sewer water line must be lower than the water servicing your house, and they got to be 10 feet apart from each other. So you can't have them, one would be leaving the house, the other one would be coming into the house. You can't have them within 10 feet. They have to be 10 feet apart on the outside of your house. This is how we find out what the slope needs to be and what the size of the pipe needs to be. You have to go through and you have to add up all of the drainage fixture units. In your assignment, which eventually you will have to do your assignment here. Oops, missed. In your assignment that has been assigned to you, this is like number 2 or something in the problem. So here it is, wastewater management. And if I look at that assignment quick, when we get down here, B, you're going to have to add up all the drainage fixture units and find out what the pipe size needs to be. So what does that mean that you're doing? Well, you're going to have one kitchen sink. So that counts as 2 units right there. Depending on the size house you're building, you may have more than one bathroom. So if your bathroom has a bathtub, that counts as 2 units. If the shower is one that goes into the bathtub, you don't count that. But if you have a separate shower stall, that counts as 2 units. Because somebody could be taking a bath and somebody could be using the shower at the same time, and they could both be draining at the same time. So far I'd be up to 6. If you have a clothing washer in your house, that counts as 2 units. If you have a dishwasher in your house, that counts as 2 units. And you just add them all up. Now, a lavatory, that's referring to the bathroom sink. If you have a bathroom sink, that counts as 1 unit. So, for example, a kitchen sink is going to drain more water than a typical bathroom sink, which is why it's less. So you just go through and you start adding up all the different things. Now, if you have 2 bathroom sinks, that's 2. If you have 3 bathroom sinks, that's 3. If your bathroom sink is large, count it like a kitchen sink. Okay? And then the last things that you're going to count up are your toilets. All of the toilets that we have are going to be 1.6 gallons. That's pretty much code now. So a flush of a toilet counts as 3 units. So if you have 2 toilets in your house, that's 6. Okay, so once you've added up all of the drainage fixture units for your house, you're going to use this chart. And if your number is 36 or less, if you have 36 units or less, you get a 3-inch pipe with a 1% slope. If the drainage fixture unit is between greater than 36 but less than 42, then you have to use a 3-inch pipe, but it has to be at a 2% slope. So 2% would be the minimum. And if your drainage unit, or if your pipe is less than 50 but greater than 42, so this is less than 50 here, this is a 4% slope with a 3-inch pipe. Now there's a big jump. If you're over 50, you're going to have to use a 4-inch pipe at 1%. There is no way you guys are going to be in that category. There's no way. But you can get up to 250 fixture units, and that would mean you'd have to use a 4-inch pipe at a 4% slope for everything to drain properly from your area. The calculation, which is what this is getting into now, is very simple. It's slope. It is rise over run. I'm not sure why everybody has a really hard time with this calculation every year when we do it. I'm going to give you a sample calculation from my house that you can use as a template when you're doing your own. I think part of the problem is because they use the word invert elevation twice in the calculation. People get very confused about what that means. So I'm going to try to define those words right now for you. Make sure you're listening carefully. Make sure you're taking notes, whatever you got to do it. But at the end of the day, this is rise over run. I need to know how far this pipe drops from right here. That's the top of the pipe. Bear with me. This is the top. So when you flush the toilet, this is where things are going to start. This is the highest it's going to be. And then it's going to go downhill until it gets to here. And there's always stuff in this pipe. This is your sewer street. This is the sewage at the street level. There's always stuff in this one. So we assume that it's half full. So it starts here at the top and it goes downhill until it gets right here. So we need to find this point and this point and subtract them. That's going to be the rise. It's actually going to be the fall because we want it to go downhill. But that's your rise. In terms of the run, that's how far it is from your house to the street. And for all of us, we're all going to use the number 108. We're just going to use 108. Don't even worry about anything else. You're going to assume your building is 108 feet from the street. That's going to make the calculation easier for everybody when you have to compare answers when we do that. So Here are some vocabulary words. This is called the drain. This is the sewer main. This is the lateral. That's the pipe that connects the house to the sewage. There's a clean out so that if things get jammed up, a plumber can come and they can clean that out. They just stick a hose down it and spray it all out. And the flow goes towards the street. So this is what I was describing. This is the invert elevation at the house. This is the center of the pipe. This is the invert elevation at the sewer main. The word invert elevation is used twice. There's the invert elevation at the house and the invert elevation at the sewer main. Please make sure you keep those two separate. The run is how far it is from the house out to the street. So Project Lead the Way gives you like 3 ways to do this. I'm going to use this last one when I do my sample. And I don't think I want to continue too much further into this presentation. That's the one that I'm going to use when we go to do it. You're going to take your invert elevation at the building. We're going to subtract the crown elevation, and then you add in half the diameter of this pipe. And when you do that, you're basically getting the number from here to here. Because you're going to take this minus this and then add that little bit in. Most of the United States has city water being treated. There are a lot of places in the United States where we still use septic systems. And since it's here, we should just talk about it briefly. Basically, what a septic system is, your water does not leave your house and go to a treatment plant. Your water leaves your house and goes to your backyard. And when it goes to your backyard, it's going to go to a tank where it sits. And every once in a while, you have that pumped out. And you add bacteria to it to help eat the sludge. And eventually, any water or liquid waste filters through into the ground soil and back into the water table. So this is what it looks like at your house. Your sewage leaves, goes to a tank. Eventually, you do have to have this pumped out, but liquid waste goes into what we call the drain field, and it's just underground and it becomes part of the water table again. So we let Mother Earth clean up that waste material, other than the fact that you do have to have this solid material pumped out of the septic tank every so often. You'll know in your house when it starts to fail. You will definitely know. So let's take a closer look at this calculation. I'm not going to save that PowerPoint. And this is the homework assignment that you're supposed to do. That's the homework assignment you're supposed to do. I'm going to go into that wastewater management folder and take a look. I did give you a sample calculation right here. So when you're doing it, this is for my house in Germantown. Like I actually took the real numbers from my house. And these are the real numbers that I would get when I'm looking at things. So for example, the ground elevation in my house is 869 feet. Now we know from working in Revit that our house is probably at the 769 mark. So you could use 769 for your ground elevation. Frost depth you get by reading a map. So that map is going to look like this right here. There it is. A map like this where you're going to look at it for the frost depth. So like for example, we're in the Milwaukee area, which is right there. So if you follow that line as carefully as you can, I can't follow it when this map's too little for that one. Maybe if I go the other way. Follow it as carefully as you can. Boom, 35. So if we follow that line all the way around, oh, I think it was this one, 35. So our house is right here in Indiana. And so you got to take that frost line and follow it over to find out what the frost depth is going to be when you're doing yours. But ours is 35 inches here in the Milwaukee area. My sewer main elevation, when I looked it up, that's right here. That's 863.25. From my house to my street was 63.4. You're going to use 108. And then I was told that this sewer pipe is 14 inches. So here are the three things I need. I need to know this distance. Well, that's easy. It's right here, 63.4 feet. I just put it right in the calculation. That distance is easy. Finding the invert elevation at the building, a little bit more challenging. Because I take my ground elevation, that's my lowest floor. I have to subtract 2 feet or whatever the frost depth is, whichever one is more. Because remember that slide in the PowerPoint presentation says you got to be 2 feet under your lowest floor, or you have to be underneath the frost. Well, in this case, the frost is 35 inches. 35 inches is bigger than 2 feet. So I put 35 in my calculation right there. 35 inches converted to feet is that number. 36 inches would be 3 feet. So this is 35 inches right here. So I'm taking my ground elevation, subtracting my frost depth, and then I need to subtract the diameter of the pipe leaving the house. Everybody's going to be using a 3-inch pipe. When you're doing that calculation, I mean, I know I said you got to add up the drainage fixture units, but it's going to be a 3-inch pipe. You're not going to have more than 50 drainage fixture units in your house. Everybody's going to be using a 3-inch pipe. So a 3-inch pipe is 0.25 feet. 0.25 feet. So if we take the 869 minus the frost minus the pipe, this is what the pipe has to be when it leaves my house. So you're going to have to calculate that. That's this bit number right here. 865.83. 865. Okay. Now, to get the crown elevation, this is different. I don't use any of these numbers. None of these numbers. To get the crown elevation, I need the invert elevation at the sewer. Well, that was told to me right there. The sewer elevation is 863.25. And then, if it's 863, I'm going to add in the diameter of the pipe. It's a 14-inch pipe. I converted it to feet. So 14 inches converted to feet is 1.1667. If I take that plus the pipe, I get 864. That is my crown elevation. That's right there. So I had the invert elevation. I added in the pipe, and now I'm sitting right there. That's my crown elevation. So I put my crown elevation number, 864 there. I put my house number there. Subtract them. And then this is half the diameter. So this number is half of that one. This is 7 inches converted to feet. And at the end of the day, when you do the calculation, you get 3.14. So when you are doing this on your own, the very first thing you got to do is you're supposed to find out what size pipe you're going to need. I'm telling you right now, it's 3-inch pipe. You got to look at the map to determine what your frost line is, or maybe 2 feet's bigger than your frost line. I don't know. But you got to look at the frost line or 2 feet, whichever one's bigger. And then you're going to have to find that invert elevation at the building. You're going to take your ground elevation of your house, minus the frost, or 2 feet, whichever is bigger, and then minus the 3-inch pipe, which is... Once you do that, you got to calculate the crown elevation. So to calculate the crown elevation, you're going to have to go up and look at where the heck the pipe is in the ground. This is the sewer line right here, and you're told that it's a 14-inch one. So this is step 2. When you do that one, you're going to be basically doing this calculation right here, and then you can put them all together to get your final. This is one that I would recommend probably doing in class before you leave, so that if you're stuck on something, you can ask somebody else that's sitting around you how to do it. And then we'll go from there on the next day.